Hey y'all, my name is Nate Moyer, and I will be leading this week's discussion intro video for Lesson 14, Finding Your Way or Animal Navigation. So the study that I chose is called Magnetic Maps and Animal Navigation, and really what it is a review study that was originally published back in 2022 in the Journal of Comparative Physiology, and it looked at probably over a dozen different studies from the 1990s all the way up until 2021 and how animals use Earth's magnetic field for part of their navigation or all of their navigation. A little bit about the authors of this study. First and foremost is Ken Lohman. He is a distinguished professor of biology at the University of North Carolina. He's been there for quite a few number of years and has got himself heavily involved in marine biology, looking at long-distance ocean migrants. Green sea turtles, salmon, as well as the Caribbean spiny lobster are some of the species that Lohman himself has studied. And he's also heavily involved in different professional organizations outside of the University of North Carolina, including the International Sea Turtle Society. Back in 2019, he actually served as the president of the International Sea Turtle Symposium. And so you could tell that sea turtles, especially green sea turtles, are a passion for Lohman. And he is definitely involved and heavily passionate about conservation of these kinds of species. The other authors involved in this study are all graduate students or associate professors within the Lohman Lab in the biology department of UNC. So looking at the study site, like I mentioned, this is a review study that was done. And so it looked at a couple different studies that happened over the last 3 decades. But a pattern did emerge that many of the studies that were focused on did occur around the coast of Florida. So looking at green sea turtles in the upper left-hand corner, you can see a map that I pulled from the study where they were testing off the east coast of Florida. And then right below that, we see a map of the Caribbean spiny lobster where the capture location was just at the southern tip of Florida. And then even over to the right, bonnethead sharks can be found worldwide, but one of their migration routes is around, you guessed it, Florida. And so this was just a map kind of showing how those bonnethead sharks using Earth's magnetic field tend to navigate during their migration periods. But then, of course, other study sites did exist with some of these. If you looked at like the Chinook salmon or the pink salmon, those occurred on the west coast of the United States. There were a couple bird studies that were done as well involving the pied flycatcher, wheat eaters, as well as Eurasian reed warblers. Those occurred over in Europe. So we did get a diverse variety of study sites, but like I said, most of them kind of occurred on the coast of Florida. I already mentioned some of the species that were involved here. Because this is a research study, we see a vast array of species involved, but most of them are marine animals. First and foremost, we see right away those green turtles pop up again. The Chinook and pink salmon I already mentioned. One thing that I was happy to read about were the red-spotted and alpine newts. They're terrestrial species, so not a marine animal. But they were mentioned in depth throughout this study. Red-spotted newts are a native species along kind of the eastern United States. They're one of my favorite species to come across when I'm walking out in the woods in central Pennsylvania. And then the Caribbean spiny lobster, bonnethead sharks, which are a worldwide species. And then one other that I don't have on here that I took note of is there's a brief mention also of European eels using Earth's magnetic field for navigation purposes. So just a little bit of background relevant information. Lohman, in a study in 2018, mentioned that this phenomenon of bird migration or the disappearance of birds in the fall and their return in the spring really was the genesis of this curiosity around animal migration and animal navigation. Where did the birds go? Why did they come back? How did they know to come back to this exact spot? How were they able to navigate where they went and how they came back? And so looking at this review study, just because it's a review study, you can see that many have come before this. Many studies have come before, and I'm sure that many will follow. And really, that's because scientists don't have a firm grasp on how and why animals are able to use Earth's magnetic field for their navigation purposes. Why are some able to utilize it more than others? Is it a choice? Is it not? Scientists are still trying to piece that puzzle together. And so I'm sure because of that, because of our wanting to understand this, that many studies are going to follow after this, trying to understand Earth's magnetic field and how that plays into animal navigation. Lohmann himself was involved in multiple studies kind of before this review on green sea turtles and on spiny lobsters. I have here in my notes that one of those studies occurred in 1994, where he did it with his wife. Another study occurred in 2012. That was for green sea turtles. In 2003, they did a study on the Caribbean spiny lobsters. But then, like Keller in 2021 did one on the bonnethead sharks. Another, Putman is a renowned name in the world of animal behavior and animal navigation. He did quite a few studies on the Chinook and pink salmon back in 2014. So there's a lot of background information here to kind of go off of for future studies, but there's still so much to be learned about animal navigation and how it relates to Earth's magnetic field. And so you might be asking yourself, why is this important? Why is it important that we understand how Earth's magnetic field affects animal navigation? And I think looking at this study and kind of having a little bit of background information myself, I've come to the conclusion that a changing world does not change our Earth's magnetic field. Uh, the magnetic field has been around for millennia, and it has it has shifted at times, but it has relatively remained unchanged. However, our world has not. We have, especially within the last 2 centuries or so, we have drastically changed the landscape of our world. And that has dramatic effect on animals and how they navigate. And I picked out kind of two examples here. One of them here in the United States, wind energy, a renewable and sustainable source of energy, it's great, has become ever more popular. And we've put up hundreds or thousands of wind turbines, especially in the Western United States. The problem with this, though, is that a lot of those wind turbines have appeared within migration corridors or kind of high flow traffic areas of different migrant species, especially birds. And these turbines, the blades of them can reach up to 300 feet long. And when they're spinning full speed, they can be spinning at about 150 miles an hour, which is really fast. And if you look at the bottom right-hand picture, you'll see that oftentimes what can happen during migration season is these large flocks of birds will fly through these turbines. And, excuse me. Oh, sorry about that. A large number of these birds end up being fatally wounded or killed because of this. And so as we change our landscape, notice how these birds are not flying around the turbines. And I think a lot of that has to do with the fact that they are following Earth's magnetic field. We might be changing the landscape, but we're not changing their actual routes and how they navigate, which is really important as we look to the future of both conserving kind of the resources that we have and using sustainable energy while also conserving the animal populations that we have and maintaining healthy migration practices in those species. And I guess to conclude, why did I choose this study? And it's because honestly, I'm just interested in the magnetic field and how that plays a role in animal navigation. I think it is absolutely astounding that a bird can simply follow using, using the force for our Star Wars fans out there. to navigate thousands and thousands of miles and wind up in the same exact place year after year. It absolutely baffles me, and I'm curious as to why some species do it more than others. Why can't we as people do it? Are people able to do it, but it's just a suppressed kind of practice that we have lost over millennia, from our roots of indigenous people to now? I don't know. But I hope you guys enjoy this week's lecture and enjoy this study as much as I have. And it's been a pleasure working with you this semester.